Folks, I need to share something with you that's been keeping me up at night for weeks. Have you ever looked up at the starry sky and asked yourself that question we've all wondered about? Are we alone in the universe? Well, maybe, just maybe, we've finally found our answer. 120 light-years from here, there's a planet called K2-18b. And what the James Webb Space Telescope discovered there might be the strongest evidence we've ever had that life isn't exclusive to Earth. I'm talking about 99.7% scientific confidence. That's as close to absolute certainty as we get in science. But before I tell you how we reached this groundbreaking discovery, let me ask you something. Can you imagine what it means to find a chemical signature that only exists because of life? Because that's exactly what we're going to explore today. So join me on this journey that sounds like science fiction, but is pure science. Let me tell you a story. Imagine you're walking along the beach and you smell that distinctive ocean scent. You know what that is? It's a molecule called dimethyl sulfide. It's produced by tiny marine organisms, like phytoplankton. Now, here's the fascinating detail. This molecule only exists in nature because of life. There's no geological process, no inorganic chemical reaction that produces it naturally. It's like life's signature. And you know where else we found this molecule? On K2-18b. It's 120 light-years away. Think about this with me. If this substance is only produced by living beings and it's there, floating in the atmosphere of a distant planet, well, can you imagine the implications? It's like finding footprints in the sand on a deserted beach. Someone was there. Or better yet, something is there, continuously producing this molecule. Because it breaks down quickly in space, so for it to be present, it needs to be constantly replenished. But before we talk about the implications of this discovery, we need to understand how this planet came to our attention. Now let me introduce you to the star of this story, K2-18b, and I'll tell you right now, this planet is going to challenge everything you think about habitable worlds. Imagine a world 8 times heavier than Earth, orbiting a star smaller and cooler than our Sun. It completes one orbit around its star in just 33 days. That would be like our year lasting just over a month. But here's what makes this place special. It's in the perfect zone. Not too close to the star to be hell, not too far to be a frozen wasteland. It's like Goldilocks' chair, not too hot, not too cold, but just right to have liquid water. And the James Webb discovered something incredible. K2-18b has a hydrogen-rich atmosphere, with water vapor, methane, carbon dioxide. It's like an oceanic world covered by a dense atmosphere. Scientists call this a Hycean planet, hydrogen plus ocean. Picture this, an entire planet covered in water protected by a thick atmosphere. Sounds like the perfect setting for life, doesn't it? And if you're finding this discovery as fascinating as I am, hit that like button to help me bring this science to more people. But how the heck did we discover all this about a planet so far away? That's where the story gets even more mind-blowing. Now, how the heck did we discover all this about a planet so far away? This is where our cosmic detective comes in, the James Webb Space Telescope. You know how it works? It's brilliant. When K2-18b passes in front of its star, like someone walking in front of a streetlight, a tiny amount of the star's light passes through the planet's atmosphere before reaching us. It's like looking through colored glass. Each missing color in the light tells us about the substances in the atmosphere. Each molecule absorbs light in a specific way, creating a kind of chemical fingerprint. The James Webb is so sensitive, it can detect these fingerprints with incredible precision. To give you an idea, one observation with Webb equals 8 Hubble observations made over several years. And that's how we managed to sniff out that special molecule, dimethyl sulfide, in K2-18b's atmosphere, like a cosmic bloodhound finding clues of life. But here comes the question you're all probably asking, how reliable is this data? Because if we're talking about extraterrestrial life, we need to be absolutely sure, right? Now let's talk numbers, but in a simple way. When scientists say they're 99.7% certain about something, what does that really mean? Imagine you flip a coin 1,000 times. Normally, you'd expect it to land heads about 500 times, right? Now imagine it lands heads 997 times. You'd think, wait, there's something fishy about this coin. That's exactly what's happening with K2-18b. The probability that we're wrong about the presence of that molecule is only 3 in 1,000. It's almost impossible to be a coincidence. Of course, in science, especially when we're talking about something as revolutionary as extraterrestrial life, we want absolute certainty. We want to reach 99.99997% certainty. We're not there yet, but we're very, very close. It's like being almost at the summit of Mount McKinley. You haven't reached the peak yet, but you can already see the view from up there. But before we celebrate this discovery, we need to talk about something important. What happens when other scientists look at the same data and reach different conclusions? Obviously, a discovery of this magnitude doesn't go unnoticed. Other scientists looked at the same data, and some said, "Hold on, I'm not seeing this." And you know what? That's fantastic. That's exactly how science should work. It's like when you tell an incredible story to your friends and they ask, "Are you sure? Tell it again." It's not because they don't trust you. It's because the story is so incredible it's worth checking twice, 3 times. Some researchers reanalyzed the data and found no convincing evidence of that molecule. Others pointed out inconsistencies. And that's perfect. Each question, each independent analysis brings us closer to the truth. Think of it this way. If we eventually discover there really is life on K2-18b, it'll be a rock-solid discovery. If we discover there isn't, we'll still have learned something fundamental about how to study distant worlds. Science isn't about being right on the first try. It's about reaching the truth no matter how many attempts it takes. What do you think? Do you prefer discoveries that are confirmed quickly, or do you value this rigorous verification process? Let me know in the comments. But regardless of the debate, K2-18b has already changed something fundamental in our search for life. Here's something that really gets me excited. K2-18b is completely changing our idea about where life can exist. For decades, we searched for planets that were Earth copies, rocky planets with thin atmospheres, orbiting sun-like stars. It was like looking for people who were exactly like us. But K2-18b showed us that life can thrive in completely different environments. Imagine a world covered by deep oceans, protected by a dense hydrogen atmosphere. It's like discovering that life can exist, not just in houses, but also in submarines. And here's the kicker. Planets like K2-18b might be much more common than Earth-like planets. They orbit red dwarf stars, which are the most abundant type of star in the galaxy. Do a mental calculation with me. If just 1% of these worlds has life and there are billions of red dwarf stars just in our galaxy, how many active biospheres would that represent? The answer will surprise you. Millions. Life might not be rare. It might be the rule, not the exception. But if that's true, what would this alien life be like? Now let's do an imagination exercise. If life really exists on K2-18b, what would it be like? First, forget plants doing photosynthesis. With that dense atmosphere, sunlight might never reach the surface. But that's not a problem. Here on Earth, we have creatures living at the bottom of the ocean around hot water vents that have never seen sunlight. They get energy from chemical reactions, not light. It's like having a microscopic chemical plant inside each cell. On K2-18b, life could be even more creative. Imagine organisms floating in the upper layers of the atmosphere, like biological balloons feeding on carbon-rich gases, or creatures in the ocean depths adapted to immense pressures using hydrogen as fuel. Life could take forms we can't even imagine. Maybe beings that communicate through chemical reactions or that change shape depending on water pressure. The universe is much more creative than our imagination, and that's both humbling and inspiring. But this leads me to an even more intriguing question. If life is as common as K2-18b suggests, why haven't we found obvious evidence of it everywhere? This leads me to a fascinating question that every astronomer has asked. If the universe is full of life, where is everybody? It's the famous Fermi paradox. Imagine a huge party where you know there are thousands of people, but you can't see or hear anyone. Strange, right? Maybe the answer is simple. We're looking in the wrong place or the wrong way. It's like trying to recognize music when you only know one musical note. If life on K2-18b exists, it evolved independently for billions of years. It might be so different from terrestrial life that we could barely recognize it. Or maybe life is so common that we're literally surrounded by it, but our technology still isn't sophisticated enough to detect it consistently. K2-18b might just be the tip of the iceberg, the first of many worlds where we'll find signs of life. What do you think? Are we alone or surrounded by life we don't yet know how to recognize? Share your theories in the comments. Stop for a second and think about what this really means. If life exists on K2-18b, we're no longer unique. We're no longer a cosmic anomaly. We're part of something much bigger. Think about the implications. All our history, our culture, our religions were built on the premise that we're special, unique in the universe. How would that change if we discovered we're just one among billions of civilizations? Would it be scary? Maybe. But it would also be liberating. It would mean we're not alone on this cosmic journey. That somewhere, maybe around K2-18b, other beings are looking at the stars and wondering if they're alone. And that should fill us with humility and responsibility. If life is precious and rare enough to be special, but common enough to exist in many places, then we have an obligation to protect it wherever we find it, including here on Earth. So where do we go from here? This is just the first page of a book we're starting to write. The James Webb will continue observing K2-18b, searching for more evidence. Other telescopes will join the investigation, and soon we'll have even more powerful instruments that will allow us to study not just chemistry, but maybe even detect signs of biological activity in real time. Imagine, in a few decades, we might be able to map K2-18b's oceans, study its weather patterns, maybe even detect seasonal changes that indicate life cycles. We're entering an era where discovering extraterrestrial life is no longer science fiction. It's a matter of time and technology. And when that moment comes, when we have absolute certainty that we're not alone, it will be the most transformative moment in human history. It will be the day we stop being Earthlings and become cosmic citizens. We've reached the end of an incredible journey, but it's really just the beginning. K2-18b taught us something fundamental. The universe is much more interesting, much more alive than we ever imagined. And we, made of atoms forged in the hearts of ancient stars, are part of this extraordinary cosmic story. Every time we look at the night sky, we're no longer looking at emptiness. We're looking at cosmic neighborhoods that might be teeming with life, with stories, with possibilities we can't even imagine. And you, who've come this far with me on this journey, are part of this discovery. Every question you ask, every curiosity you feel, every moment of wonder at the cosmos contributes to this extraordinary search. If this video sparked your passion for the universe, if you want to keep exploring these mysteries with me, don't forget to subscribe to the channel, turn on notifications, and share this discovery with people you love. And tell me in the comments, do you think K2-18b really harbors life? I want to know your theories because science is more powerful when it's shared. And remember, we are stardust that gained consciousness. We are the universe trying to understand itself. And now, maybe for the first time, we're discovering that this journey of cosmic self-knowledge isn't lonely. Keep looking up, keep wondering, keep dreaming. The cosmos is full of surprises waiting for us. See you in the next video, where we'll continue exploring the most fascinating mysteries of the universe. The cosmos is calling. Let's answer together.